AP Statistics, your life is about to change for the better because we are starting our very first unit of probability. It's magical. All right, so of course we are in Unit 4 in your book. This is going to be chapters 14 and 15. And yes, probability is in fact its own branch of mathematics, which I know for some of you will be a little disturbing. It is a whole branch of mathematics dedicated, of course, to describing the pattern of chance outcomes. So when you hear people say, what's the probability of that? What's the chance of that happening? What are the odds of this? That's what we're talking about. We are talking about a whole branch of mathematics known as probability. Okay, so of course, when we talk about probability of an outcome, it is a proportion of time something would occur over a series of repetitions. So proportion implies, of course, that we are dealing with a fraction. We will talk more about that in depth later on. This video is just a probability overview, and then some of the things we'll talk about in this video, we will have more specific videos about some of those items in later videos. Okay, so for any random variable, each attempt or trial course is going to generate an outcome of some kind. And we're already familiar with these words and this verbiage because we've talked about simulations. So yes, there is a connection there. So the sample space, also known as just a capital S of a random variable, is your set of all possible outcomes for the variable. In other words, if I were to flip a coin, my sample space would be, it can either land on heads or tails. So my sample space would have two outcomes to consider. If I were flipping two coins, my sample space would look something like this. I could get heads for both of them. Hold on, I didn't mean to write it that way. I can get heads, 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 tails, tails, heads, or tails, tails. So if I'm flipping a coin twice, those would be my sample space. So all of my possible outcomes. All right, sampling can be done with or without replacement. Now, what does that mean? Well, that means, let's say I am drawing a card out of a whole deck of 52 cards. All right. If I take the card out and leave it out, that is without replacement. I'm not placing it back in the deck. So if I leave it out of the deck, that means that all subsequent probabilities thereafter are going to be affected by that, and I will have one less card to choose from. So it is important when you're thinking about with or without replacement, it will change your probabilities. So again, we will talk about that in an example and in later videos. So an event, oh, the handwriting, out of control, Miss Griggs. The heck yo. An event is an outcome or a set of outcomes for a random variable. So we'll be using words like event and sample space and trial and outcome and all of that. Now, this is a very important idea here. Disjoint events are also known as mutually exclusive. And this just means that we have no outcomes in common. Another way to think about it are events that cannot occur at the same time. So an example of this, if I've got a die and I'm rolling it, I can't get a 3 and a 2 at the same time. Okay, those events would be mutually exclusive of one another. When we think about events being independent, what happens for a lot of students is that they get this idea of disjoint or mutually exclusive mixed up with independence. And you need to understand that these are different things. So when we talk about events being independent, as the name implies, it means that one event does not influence the outcome of another. Each individual event is completely independent of another. For instance, if I am rolling 2 dice, well, whatever the first die lands on has absolutely no effect on what the second die is going to land on. Okay, so those are independent events right there. So the thing you need to remember about this is that being mutually exclusive and independent are two separate ideas, and you have to be certain that you don't confuse them, and you have to remember that disjoint events cannot occur together, therefore they can never be independent. So if you have mutually exclusive events, they are never going to be independent. It's never ever going to happen. All right, so as we move through this, we do have a very important concept in this unit known as the law of large numbers. What does that tell me, Miss Griggs? Well, the law of large numbers tells me that if I do enough trials, I will eventually get a real probability or a real outcome that mirrors the theoretical probability. What does all that mean? Well, think about it this way. If you've got a coin and it can land on heads or tails, that's a 50-50 shot that you'll get heads or tails. So if I flip a coin 10 times, am I going to get 5 heads and 5 tails? Probably not. But if I flip that coin 10,000 times or 100,000 times, guess what's going to happen? Eventually, that's going to even out, and about half are going to be heads and half are going to be tails. That's what the law of large numbers tells me. It tells me that theoretically, in a situation where I have two outcomes, theoretically, if I keep doing it and if I have an increased number of trials, I will eventually see a situation where I get half tails, half heads. So that is what my law of large numbers implies. All right, the other thing we need to talk about is a probability distribution. And all of these things I'm talking about are going to show up in examples and in the specific videos that I'm going to do for them. All right, so probability distribution for a variable is just a table, and it's made up of all of my sample space and the individual probabilities that I can have within that sample space. So again, I'm going to show you what that looks like in an example. So the three very important rules that apply to probability distributions, where S represents my sample space and X is any event in the sample space. Rule number 1 is the probability, just bear with me while I write this out, the probability of any event is between 1, dang it, why can't I write? Is between, actually, let's start at the low end, between 0 and 1. In other words, the probability of any event is always a decimal or a fraction. All right, so you can think about it like this. The probability of X is greater than or equal to 0 and less than or equal to 1. That's rule number 1. Rule number 2, the sum of all possible outcomes is 1, no matter what. Because the probability of something happening plus the probability of it not happening is the total of 1. That is what that means. So the probability of the sample space happening is 1. All right, rule number 3. The probability, I'm just going to abbreviate that. The probability that an event does not occur is 1 minus the probability the event does occur. All right, so in other words, that means that the probability of A sub C is 1 minus the probability of A. What does that mean? Well, the complement A sub C is the complement. So the complement just means the opposite of something happening. So the probability of A, the complement is the probability of not A. So you can think of the complement as the probability of not A. So the probability of A complement is 1 minus the probability it will happen. So the probability of not equals 1 minus the probability it will. Okay, that is what that means. All right, the union of two events is when either one or the other or both events occur, and the intersection of two events is when both A and B occur. Now, one of the big issues in probability is figuring out whether you're adding your fractions together or multiplying your fractions together. When you are dealing with an OR situation, you are dealing with adding things together. When you are dealing with an AND situation, you are dealing with multiplication. All right, so addition for OR, multiplication.